Hi, and welcome to this video manual where we're going to take a look at NAVconfig. NAVconfig is the application that is used to create and manage configuration files for a number of different OXTS products. A configuration file tells a product how it has been installed in a vehicle and provides important information the product needs to know in order to operate correctly. Whenever you install an OXTS product in a new vehicle or change something about the current installation, moving one of the antennas for example, you need to send an up-to-date configuration using NAVconfig. NAVconfig actually sends and receives data via Ethernet, so in order to see your product when it's connected to the PC, your computer must be using an IP address in the same range as your product. For that reason, it's important that your PC is correctly configured and that you know the product's IP address. By default, the IP address of an OXTS product begins with 195.0.0. The final part of the IP address is then made up from the last two digits of that product's serial number. For example, if the serial number of your product is 2014, then the default IP address of that product would be 195.0.0.14. In order for your computer to see the OXTS product when connected, its IP address must also take the form 195.0.0. but the last octet of its address must be unique on the network. You can manually configure your computer's IP address by navigating to the Ethernet adapter, right-clicking on it and selecting Properties. Select Internet Protocol version 4, then click the Properties button. A Properties window will open where you can tell the computer to use a specific IP address. Enter an IP address from the same range as your product, but make sure the last octet of the address is different and also make sure no other computers on the network are using it. We'll use the number 7. Click on the subnet mask and the computer will automatically populate these values. You can then shut the window. The second thing to mention is that even if your computer and OXTS product are on the same network, you need to make sure your firewall isn't blocking NAVconfig. The first time you run NAVconfig, your firewall will pop up a warning to ask if this program should be allowed to use the network. You need to allow this in order to configure your product. Once the software supplied with your product has been installed, NAVconfig can be started by clicking on the Start menu, then All Programs, and scrolling down to the OXTS folder where you will see the program's icon. Although an Ethernet connection is required in order to send a configuration to your product, NAVconfig is actually an offline editor. That means you can create and modify configurations without having a live product connected. To make the configuration process as easy as possible, it's been divided into 10 steps. Depending on the product you're going to configure, you'll notice that sometimes not all 10 steps are used. The software will automatically grey out unnecessary steps and change the descriptive terms used on the left-hand side depending on the target industry. However, in most cases, the process remains the same. The first step in the process is to tell the program what sensor you intend to configure. It needs to know this in order to select the correct product template and also to change the program interface. For instance, when I select the RT3000 family, the text in the top left-hand corner changes to reflect this. These changes propagate throughout the software so you can always see what family of sensor is being configured. In this case, we're going to configure a dual antenna Survey Plus. The dual antenna version of the Survey Plus is called the Survey Plus 2. And when I select that model, you'll see the secondary antenna over on the left becomes active. There's only one product generation to choose from, and it's already selected, so I can move on to the next step. Incidentally, if you only use one type of OXTS product, you can select the Always Use This Product option at the bottom of the window, and each time you start NAVconfig, it will automatically select that product and move on to step 2. Step 2 is where we tell the application how we want to create our configuration. For instance, we might be creating a new configuration from scratch if this is the first time we've installed the product in this vehicle, in which case we would choose the Use Default Settings option. The Read Settings from Folder option can be used to open existing configurations that have been saved to the computer's hard drive. When this option is selected, a new control appears underneath so you can navigate to where that configuration is stored. The Read Settings from an RD File option is similar but with a subtle difference. RD stands for raw data, and these are the data files that the product creates when used. So imagine you had conducted a measurement some time ago, but forgot to save a copy of that configuration on your hard drive. If you need to get that configuration back, to use again for example, the Read Settings from an RD file can do this. Simply click on the Browse button and navigate to the RD file that was created using that configuration. If you know the configuration you want is still loaded into your product, you can simply read this back to the PC by selecting the option Read Initial Settings From. The product will need to be powered up and connected to the network for you to select its IP address from this menu. In this case, I'm going to select Use the default settings, as this is a new installation. With that selected, I can either click the Next button or click the next available step on the left-hand side, which takes us to the Orientation step. The Orientation page is where we tell the product how we have it mounted in a vehicle. We need to do this for several reasons. Most importantly, because we want our measurements to be output in the vehicle's coordinate frame and not in the coordinate frame of the inertial measurement unit. Coordinate frames are explained in the product manuals, but it's worth taking a moment to look at two of them now. Inside each of our products is an inertial measurement unit, or IMU for short. The IMU measures acceleration along its X, Y, and Z axes. It also measures the angular rate about its X, Y, and Z axes. The orientation of the IMU axes are clearly marked on each product, and the position of the measurement origin is defined in each product manual. The vehicle being measured also has a coordinate frame, called the vehicle frame. Just as the IMU has X, Y, and Z axes, so does the vehicle, but it's not always possible to install your product in a way where the axes of the IMU frame match those of the vehicle. Luckily, by telling your product how it has been installed in a vehicle, it will rotate its outputs into the vehicle's coordinate frame, and that is what we are defining on the orientation page. So let's assume I've installed my product like this. In the orientation settings page, I need to tell the application that the product's y-axis points towards the vehicle's left, while the product's z-axis points forwards in the vehicle. As a visual aid, the currently specified orientation is shown on the right-hand side of the window. You can see the icon now reflects my installation, so I know it's correct, and the product will be able to work out how the vehicle is moving based on its own measurements. Although you don't need to line up the product's x-axis with the vehicle's x-axis, and so on, it is important to install the product as squarely as possible in the vehicle. The main effect of any misalignment will be to give some lateral velocity measurement when the vehicle is travelling in a straight line. It won't be possible to keep the product truly square during an installation, but by keeping any errors to a minimum, our software can reduce those errors so that they become insignificant. The next step in the process is to tell the product where it is in relation to the primary antenna. We need to do this because although the GNSS receiver is housed inside the product, the position measurement the receiver generates is centered on the antenna itself. However, the measurements from the INS are centered on the measurement origin, even if they're later displaced. So the system isn't interested where the antennas are, it only cares where it is. By telling the product where the primary antenna is in relation to itself, it can translate the GNSS measurements to its own location, providing all the information it needs. Of course, if you're working with a product capable of 1 centimeter accuracy, then it needs to know the relative XYZ position of the antenna to much greater precision than that, which isn't easy to measure when things like the vehicle roof are in the way. Thankfully, the product can do the hard work for us. During the warm-up phase, it compares measurements from the IMU with those calculated by the GNSS receiver. It can then use that information to work out precisely where the antenna must be in relation to the IMU. The downside is that this places a huge load on the system processor because it has to consider each and every location the antenna might be, and this can also take a long time. So to speed things up, the system takes the measurements entered on the primary antenna page and uses them to define a much smaller search area. That's why it's so important not to overstate the accuracy you measure with on this page. Saying you measured with extreme accuracy, if you didn't, won't make the product any more accurate. All it really does is increase the chance that the antenna's real position falls outside of the defined search area. In other words, you're telling the system to search in the wrong place. I'm going to specify that the primary antenna position is 0.5 meter in front of the product's measurement origin, 0.5 meter to the left and 0.5 meter above. You can see the default accuracy is 0.1 meters, so I need to be sure that the measurements I entered are correct to ± 10 centimeters. The next step is to enable the secondary antenna. If the antennas are level, within 3 degrees when viewed from the front or side, then check the antennas are level option, as this will speed things up during the warm-up procedure. Unlike the previous antenna measurements, the product won't improve this measurement in use, so it's important to measure as accurately as possible. The measurement needs to be accurate to within 5 centimeters. Take care to measure from the center of one antenna to the center of the other. The separation of the antennas should be somewhere between 1 and 5 meters. It's also worth mentioning that the antennas should be mounted identically to achieve the best results. This means the cables need to exit the antenna in the same direction when viewed from above, like this, and not like this. They should also be orientated in the same way, so it doesn't matter if they're mounted like this, or this, but they shouldn't be mounted like this. The wheel configuration page is only relevant for land-based vehicles, and you should make sure the non-steered axle option is not selected in airborne or marine applications. In this case, we're installing the product in a mobile mapping car, so I'll tick this option. This particular feature uses the characteristics of land vehicle motion to improve the lateral drift performance during GNSS blackouts. It's worth pointing out that this is not suitable for vehicles with all-wheel steering. The measurements we need to enter are the XYZ distances between the IMU measurement origin and the center point of the rear axle at ground level. Again, the illustration changes to confirm we're defining the correct position. The options page contains a list of features that can be used to tailor your product for different applications. Because of the number of options and how complex some of them are, we're not going to cover them here. Instead, you'll find individual videos covering each one in detail and links to those on our website. For now, I'll just point out that the default options are suitable in most applications, and so I'll leave them as they are. Once we arrive at the commit page, our configuration is complete. The only thing left to do is send it to our product so it can be used each time the product is powered up. If you want to send the configuration now, you can simply connect your product to the network and power it up. You will then be able to select its IP address from the drop-down menu and click Commit. Once the configuration has been successfully committed, a confirmation message will appear. At this point, you can exit NAVconfig, knowing that your configuration is uploaded to the product, or you can save a copy of the configuration on your PC by clicking Next. I won't do that now in order to demonstrate something on the next page. The Save Finish page is the last step of the process, but not a mandatory one. To save a copy of the configuration on your local hard drive, select the Save Settings in the following folder option and choose a destination. Our configuration actually consists of several files, so we recommend saving each configuration in its own folder to make finding them easier. You can see that the application is warning us that we haven't yet committed this configuration to a product, even though one may be available on the network. If we had have committed this configuration in the previous page, this warning wouldn't be visible.